So looking at the first one, we're going to do plus or minus square root of 225 times the square root of a to the 16th times the square root of b to the 36th. What is my index here?
2.
Index is 2. We look right here. Don't see a little number, and so we know our index is 2. Why does that matter? How do I use that? Yes, we have to divide the 16 and the 36 by the index. So I have a to the 16 divided by 2, which gives me a to what power? A to the 8th power. Times b to the 36 divided by 2. 36 divided by 2 is what? 18, so b to the 18th. And now we just need to deal with this square root of 225. How can I break that down if I have no idea what the square root of 225 is? What can go into it? 15 can go into it. Can anything else go into it? 5. That was the one that I saw first. If you know that it's 15 times 15, that is fantastic. You can jump right to square root of 225 is 15. If you don't know that, then we're going to look at, is it even or odd? If it's odd, can 5 go into it? In this case, 5 can go into it. What is 225 divided by 5, just out of curiosity? 45. So 5 times 45. What can go into 45? 5 can go into 45. 45 is 5 times what? 5 times 9. I like that because I know that 9 is a perfect square. What is the square root of 9? Yeah, square root of 9 is 3. What about the square root of 5 times 5? 5. 5 times 5 is what? So that would be the square root of 25, which is 5. We've got our plus and minus out in front. I multiply those two together. We have a to the 8th and b to the 16th. What do I get when I multiply the 5 and the 3 together? 15. So if you knew right away that it was 15 times 15, you got 15, a to the 8th, b to the 18th. If you didn't know that 225 was 15 times 15, you could have broken it down another way and gotten the exact same answer. What is my index on the second one? 3. Why does that matter? What am I going to do with this? Divide the 12 by the index. I take 12 divided by 4 and I get what? Or sorry, not by 4. I'm dividing this by what? What's my index? It's 3. My brain wrote down the wrong number. I think in my head I divided and wrote that down. So this is going to be a to the 4th. There we go. So far, so good? All right. We are going to be in your books, starting on page 317. We're going to learn about something today called a rational exponent. And actually, I just had you do this on the bell work. This right here is a rational exponent. A rational exponent is an exponent that I can write as a fraction.
378.
317. An exponent that can be written as a fraction is a rational exponent. Page 317. 317. Rational exponents. So we're going to have two different forms that we talk about here. We have exponential form versus radical form. Exponential form is going to be something written with an exponent. A radical form is written with a radical, so something that has a radical symbol in it. For example, if I had something like this, if I had something like that, the exponential form of that, my index becomes the denominator when I'm in exponential form. So this would be a to the 1/3 power. The index goes on the bottom. So if I have something under a radical, I can rewrite this in exponential form where the index becomes the bottom part of a fraction. I can do this even if my radicand, the part under the radical, has an exponent with it. What's my index on this one? 3 is my index. This is my exponent. I can write this in exponential form. My index would still be the denominator of the fraction. And my exponent becomes the numerator. This right here is called a rational exponent. Because it is a fraction. If I have an exponent that is a fraction, it is called a rational exponent. When it's in radical form, my index becomes the bottom, the denominator, when it's in rational exponential form. All right. One more thing that I want to show you guys before we do some practice with this. Let's pretend I have something written in rational exponential form. Let's say I have x to the 5/7. This is exponential form. Guys, we're going to practice going back and forth between these two forms, so please make sure you pay attention. If I wanted to write this in radical form, there are two different ways that I could write this particular one in radical form because I have a numerator that is not a 1. What's the index here? I'm looking right down here. The 7 is the index. The denominator is your index. So when I go to put this in radical form, the 7 goes out here. So the x is going to go underneath. It's going to become my radicand. And I said there were two different ways that I could write this. They look different, but they have the same meaning, and it has to do with where I put my exponent. That exponent of 5 can go underneath the radical and be an exponent on the x. Or it can go outside the radical and be an exponent on the whole thing. Does not matter which way you do it. You do need to be familiar with both of those, and that either one of those would be the same in their exponential form. So it's written in two different ways, but they have the exact same meaning. That numerator can go in either spot. Make sure this actually looks like a fraction here. All right. So I want to practice down at the bottom of the page. Let's look at example number 3. What is the exponent in this exponential form?
3, 2,
What is the exponent?
4.
It's not just, yes, we've got 4. Here's my exponent. What is my index?
Oh, so the denominator is the index.
The denominator is our index. In exponential form, the 4/3, that whole thing is my exponent. But we're going to go and write this in radical form. So what would this look like in radical form? I've got my radical written. 3 goes right here. And then x here with an exponent of 4. Or how else could I write it and still be correct?
The 3 outside, the x inside, and then parentheses, and the 4 outside.
Yes. Both of those are correct. I want to take this guy right here and write it in exponential form. There's only one way to do that. Which piece is the index? 5 is the index. Where does that go when I'm writing it in exponential form?
Outside, denominator.
Denominator. It's going to be my denominator. So what do I do with the squared? Put this in the numerator. So there it is in exponential form. And again, this right here is called a rational exponent. When my exponent is written as a fraction, it is called a rational exponent. Let's look at another example. You guys are going to need to flip the page for me to 318. They've filled in most of these spaces for us, but I want to show us what the important parts are, even though they've filled them in for us. The expression C equals 1 plus RT can be used to estimate the future cost of an item due to inflation. C represents the current cost of the item. What does R represent? Yes. R represents the annual rate of inflation, right there. So this is a rate. What do you guys think the T stands for? Time in years, yes. Write an expression in radical form. So they asked for radical form. For the future cost of an item 3 months from now. But we said our time was being measured using what units? Time, T, is being measured using what units for time? Years. So first I need to know how much of a year is 3 months? 3/12. You're absolutely correct. How much of a year is 3 months? So we do 3 out of 12. Can I reduce that fraction down at all?
Yes.
Yes, I can reduce it down. I divide them both by 3 to 1/4. So this is my time, T. And they wrote that down for me right here. They put it in for the exponent. What did they tell me about the inflation? Right at the very end of the paragraph, what did they tell me about the inflation? 4.7%. I'm not allowed to use percents in my formulas. Percent is a compound word. Have you guys learned about compound words in English? Yeah. Words like cannot, where you smash them together, you make cannot. It's those two words that have been smashed together. Percents work the exact same way. Per, what does per mean? For each or for every. And then cent. How many cents are there in $1? 100. So this says out of 100. All right, 4.7%. I want to take this out of 100%. So this way my percents cancel top and bottom. Somebody grab a calculator for me real quick and tell me what you get when you divide those two, because we need to get rid of that percent sign. I can't do this problem with the percent sign there. How much is it? 0.047. This is R. That's where they got this from. And they put it in the formula in the place of R. Are there any like terms here that I can combine together? Are there any like terms here that I can combine? The 1 and what? 0.047. What happens when I add 1 and 0.047? 1.047. And then I'm supposed to write this using radical form. So where's my index? The denominator is my index. What's the exponent then? A 1. Do I need to write it down if it's a 1?
No.
No, I only need to write it down if it's something other than a 1. Okay. Let's look at this guy next. Example number 5. Yeah, they put almost all the work down, which I really don't like. It doesn't give us a lot of room for practice here. One thing I want you to note, though, anything that I'm writing up here, you guys should be writing down in your notes so that you can follow along with it later. Do you guys see that negative with the exponent?
Yeah.
A negative with the exponent means to write it as the reciprocal. Write the base. In this case, my base would be 32. Write the base as the reciprocal. What does reciprocal mean? Flip it over, yep. We're going to flip the fraction. In this case, that means we would have to make it a fraction and put that down on the bottom. So notice when they rewrote this, are the 2/5 as the exponent negative anymore? No. Move it to the bottom. Not negative anymore. So another example of this would be if I had, say, 3 to the negative 4. How should I rewrite that so that it's not negative anymore? 1 over 3 to the 4th, yes. All right, so the first thing we do whenever we see a negative exponent is we're going to write it as the reciprocal. It's going to go down to the bottom of a fraction. And then your book did something kind of weird here. They said that 32 was the same as 2 to the 5th power. Let's figure out where they got that from. Thank you, sir. We're on page 218 in your book, or 318, sorry, 318 in your book. All right, let's take 32 and see if we can break this down. Give me another way to write that. What goes into 32? 2 goes into 32. This would be 2 times what? 2 times 16. Can anything go into 16? I heard 4. That'd be 4 times 4, right? Can anything go into 4? 2. So this would be 2 times 2. That gives me that 4, right? And I can do the same thing here. That would be 2 times 2. That would be my other 4. How many times do I have 2 written down here? 5 times. This is 2 to the 5th power. So 32 is the same thing as 2 times itself 5 times, which is the same thing as 2 to the 5th power. Whenever I have things that have the same meaning, they are equal. If I see it written one way and I'd rather have it written another way, I can swap it out. Kind of like if you ask somebody to make change for you. You have $1 and you need 4 quarters. Is that equal value? Can you exchange that even though it looks different? Yes, 4 quarters for $1 would be an equal exchange. Exchanging 32 for 2 times 2 times 2 times 2 times 2 would be an equal exchange. 32 is the same thing as 2 to the 5th power. And then we've got these exponents here, 5, and I have this 2 to the 5th on the outside. We're going to multiply those together. How do I multiply a whole number with a fraction?
Make the whole number a fraction.
Make the whole number a fraction by putting it over 1. And then what do I do with it? Yep, we multiply straight across. Thank you. 5 times 2 gives me what? 10. 1 times 5 is?
1 times 5, sorry.
That's okay. 1 times 5 is 5. 10 divided by 5 is 2. So this becomes my exponent. This would be the same thing as 1 over 2 squared. That's what we did with the exponents. Here's the exponents. This 2 right here is that 2 right there. That didn't change. The exponent was 5 times 2 to the 5th, which we just did right here. So we simplified our exponent, and we got a 2 when we simplified our exponent. It's kind of confusing because they're both the same number. What is 2 squared? 4. So this is 1 over 2 squared, or that's the same thing as 1 over 4. There is one more example that I want to do with you guys. It's got a couple parts to it, and then we're going to be done for the day. Yep. All right. Last example. First one, they have pretty much completely filled in for us, but it gives me a chance to talk about what's happening here and a rule of exponents. Do you guys see how we have x multiplied by x? And each of those x's has an exponent with it. When I am multiplying the same base, because it's x, and they have powers, we add those exponents. So that's what they're showing me right here. What do I have to have in order to be allowed to add fractions? Yes, we're going to need a common denominator here. What should my common denominator be?
3. 6.
6. What do I multiply 3 by to get 6? 2. So I'm going to multiply top and bottom by 2. That's where this 4/6 came from. How do I add 4/6 and 1/6? Add your numerators. 4 over 6 plus 1 over 6. We add just the numerators together, and that's how we got 5 over 6. So far, so good? All right. I'm going to skip part B for just a second so that we can practice the skill that they just showed us in part A. Look down at part C. What are we multiplying together? What are my bases? Not my indexes. My base is z and z. Are those the same? If they are the same, then what do I do with the exponents? Yes. Only if those bases are the same am I allowed to add the exponents. If they're not the same, then we just write down each letter with its exponent. And they have to stay separated. Good question. If the letters are the same, then I can add the powers. Or if the numbers are the same, if that base is the same, then I can add the exponents. If it's a different base, if it was z and r, I couldn't do anything with it. All I can do is just recopy what I see in front of me. All right, so I'm going to have z to the power of negative 1/3 plus 3/4. What am I going to need here? Yes, we need a common denominator. What should my common denominator be? What do I multiply 3 by to get 4? I like 12. What do I multiply 3 by to get 12? 4. Multiply top and bottom by 4. What would I multiply 4 by to get 12? Multiply top and bottom by 3. So on the bottom of the first fraction, I have 3 times 4. On the bottom of the second fraction, I have 4 times 3. I'm going to get a common denominator here. So z to the power of negative 4 over 12 plus what? Plus 9 over 12. Do I have a common denominator here? Yes. So I'm ready to add these together. What is negative 4 plus 9? 5. So I have 5 over 12. Is this exponential form or radical form? This is exponential form. How do I know? Yes. My exponent is a fraction, but not only that, what symbol is it missing?
R.
Yeah, it's missing that radical symbol. If you see a radical symbol, then it's been written in radical form. Let's look at what the radical form would look like. And then we'll go back and do part B. How many different ways could I write the radical form and still be correct? I can write it 2 different ways. Yes. What would my index be here? Exponent, or sorry, not exponent. Index would be 12. Z goes under here. What could go underneath there with Z? An exponent of 5. Or I could write it still with a radical, still an index of 12, still have Z under here. Where else could I put the 5? Outside of parentheses. Those mean the exact same thing. All 3 of those things mean the exact same thing. They're just written in ways that look different. We say they are equivalent when they have the same meaning, but they look different. All right. One last problem, and then we will call it a week. Part B. What do you notice about the exponent in part B? There's only one. What else do you notice about it? It's a negative. We have a negative exponent. So what does that mean? We have to flip it. So I'm going to write this as 1 over y to the 2/3. Now here's the thing about exponents and radicals too. I don't want radicals. I don't want exponents that have denominators on the bottom of a fraction. So I need to make that fraction a whole number. What could I add to 2/3 to get a whole number? 1/3. So I am going to multiply this top and bottom by y to the 1/3. That would give me y to the 1/3 in the numerator. Down in the denominator, I have y to the 2/3 times y to the 1/3. Are these the same? Yes. Since they are the same, what do I do with the exponents? I add them. Do I have a common denominator? Yes. What is 2/3 plus 1/3? Yep, 3/3 or 1. So this would be y to the 1/3 over y to the 1st power. I am allowed to leave it like that, but I'm not allowed to leave it with fractional exponents down in the denominator. Yes, ma'am. What would you add to 2/3 so that that fraction becomes a whole number? Well, if I had 3 over 3, that reduces down to a whole number. So we were looking at like, what could I add to the 2/3 so that when I add that fraction together, I get a whole number. And we came up with 1/3. Does that make sense? That's where we got that from. Did you have a question, Tony? Okay. All right, that is everything that we need to cover for today. Homework is due on Tuesday. I do not see you guys on Monday. That's why your homework is not due on Monday. We have a long weekend, a 3-day weekend. Homework is due on Tuesday.